Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 16th, 2025, about 4 days ago. This paper proposes PyFlow, a policy-based few-step generator that keeps teacher-level integration accuracy with just one network call per step, hitting a 1 NFE FID of 2.85 on ImageNet 256. The paper is titled PyFlow, policy-based few-step generation via imitation distillation, and as we'll see later, the implications for model training are quite significant. Beyond the headline, the method preserves diversity, avoids shortcut mismatch, and scales to large text-to-image teachers with better diversity at 4 NFEs while maintaining quality. Alright, the introduction set the stakes for fast few-step generation. Figure 1 presents high-quality 4 NFE text-to-image results, which retain coherent structure, fine details, and readable text while avoiding diversity collapse. The collage of sample outputs demonstrates consistency across varied prompts, from portraits to stylized scenes. The schematic at bottom left illustrates the policy-based flow. One network call predicts a policy, then many cheap solver substeps integrate the ODE. The bottom right panel reinforces the positioning among VAE, GAN, and diffusion flow. Alright, Figure 2 compares 3 generation strategies side by side. Panel A depicts the teacher flow, which needs many network calls and many integration steps to track the trajectory. Panel B shows the shortcut student that jumps directly, using few network calls and few steps, which tends to lose intermediate states. Panel C illustrates the policy-based approach that keeps few network calls yet restores many cheap integration substeps via a learned policy, so solver accuracy and diversity are preserved. So the previous figure contrasted strategies. Figure 3 shows how on-policy imitation distillation trains the policy. The student G-Phi outputs a policy, then a detached rollout traces its own trajectory to sample intermediate states. The legend at right distinguishes teacher velocity in green and policy velocity in blue, which the loss matches using simple L2 flow matching. The left module highlights stop gradient with optional dropout, so training stays stable while the teacher corrects deviations along the rollout. So the training pipeline was clear. Table 1 reports 1 NFE results on ImageNet after about 40,000 iterations. The GM policy leads, with K equals 8 giving FID about 3.07 and the best recall near 0.57, while K equals 32 pushes inception score to about 342. The DX policy trails and varies with grid size, which signals sensitivity to its end setting. The GM dropout ablation shows dropout improves both FID and recall over no dropout. Okay, Table 2 compares few-step IT models on ImageNet. The two-step block shows that FACM reaches the best FID at about 1.52, while the GM policy with REPA lands near 1.97. The one-step block is the headline. The GM policy with REPA posts a 2.85 FID, which beats mean flow's 3.43 and tops prior shortcut and ICT baselines. These gains arrive without extra network calls per substep. So after those ImageNet few-step results, Table 3 summarizes text-to-image performance on COCO and HPSV2 prompts. The GM policy at 8 steps matches the teacher closely, with teacher-aligned FID about 12.6 and patch FID about 15.9, beating turbo and hypervariance. At 4 steps, it cuts teacher-aligned FID to around 14, far below SenseFlow. The QN block shows similar gains, and the data-free student stays essentially tied. So, Table 3 showed strong metric gains. Figure 4 presents side-by-side grids generated from the same initial noise. The left column shows PyFlow samples that vary structure and layout while staying close to the teacher's composition. The middle column, which contains teacher images, anchors the comparison. The right column shows VSD students that repeat layouts, often producing near-symmetric scenes, so diversity collapses even when visual quality stays high. Wrapping up, 2 takeaways stand out. The policy-based student decouples solver accuracy from network cost, giving dense ODE integration with just a few calls, and the imitation distillation keeps teacher-level quality while restoring diversity. The broader implication is faster, simpler training that scales to large text-to-image models. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.